So let's first take a look at that how Cassandra or any NoSQL which does not read before writes, and I'll explain all these terms as we move on forward, right? Why this is important, and let's actually experience what happens when you get an upsert. Anybody has tried that in Cassandra? No? Okay, let's see it. So what I'm going to do is, in Etherpad, I'm going to copy paste a couple of create key spaces, create tables, and all of that. Please copy and paste that in your SQL prompt, and let's figure this thing out. Okay, so let's create the key space called stockdb. Guys, can you analyze what's coming up in Etherpad? Don't copy and paste it at the moment. Right, can you analyze what's coming up in Etherpad, line number 62? Line number 62, can you analyze, don't copy and paste it just yet. Can you analyze and try to find out what this thing will do? If you had a simple RDBMS. If you had an RDBMS, what would this line do? Yeah, it actually won't do anything. Right, it will basically say 0 rows found, nothing left to be updated. True? Can you now try this in Cassandra and do a select star from? Copy paste line number 62 and then do select star from and observe what's happening. It inserted, didn't you? Didn't it? It inserted the value. Why did it insert the value? That is correct. The where clause is nothing but the primary key, if you notice very, very closely. Guys, what actually happened here is an upsert. As in, if the value is there, it will go out there and update. If the value is not there, it goes out there and inserts. The reason why it works like that is because Cassandra will never check the existence of a particular record beforehand. As in, whenever you are trying to insert or make any alterations, which is also called in Cassandra's world called mutation, right? Mutation is a change of state from state A to state B. Whenever a mutation comes in, it just doesn't check what the existing value was. It just goes out there and simply creates an entry in its file system. So what ends up happening is you've got the older value, now you have the newer value. The newer value beats the older value based on timestamp. Got that? So what will end up happening is when you do a select, it will not worry about the older value, just goes out there and fetches the newer value on the disk. All right? This process is called as upsert. Now, for those who are actually looking at considering Cassandra and migrating your database workloads into Cassandra, guess what happens? Your entire DAO layer has to be rewritten. Your complete data access object has to be rewritten. Don't you think? Why? Because the database tells you 0 rows updated, so you know the row doesn't exist. The database tells you that, hey, you know what, the primary key already exists, so I can't insert. Got that? You are not going to get any kind of such warnings from a NoSQL. So be very careful when you write your applications. I know writing applications probably will not be the focus you're next, but in case you have an application that you are evaluating, right? So please be very careful that these things are taken care of. This is not within the scope of this, but just to kind of let you know, what it did was an insert. Now you're wondering what kind of an insert is that? I just issued a delete command. How can that potentially insert anything? It's called as I would use the word tombstone. So it issued something called as a tombstone, which is a marker for deletion, which essentially says that the existing record, if any, from this point forward has been marked as deleted. Got that? So you just inserted a soft delete. Got that? That's what it's doing. Okay? The reason because if I just now mentioned that any insert overrides the previous values, if any, by virtue of it being the latest. In other words, it beats it by timestamp. So here's got a delete, which has got a timestamp 1, and here's a new value that you're inserting, got timestamp 2. Timestamp 2 being newer overrides this. So you continue to get that value. Otherwise, what will happen is at any point in time, if you delete anything, and if that supersedes subsequent and future as well as past, then you will never be able to insert any value with that particular primary key, which won't be a good database operation. You are next in line. The database will go out there and read all the values of a particular table, right, depending on your where clause. And what might come back is actual values and soft deletes all in one read. If you notice yesterday, I said that there is, let's say the primary key, and then I drew like this. You remember? Right, in the context of wide row store. So what are these? These are all nothing but records. This one could be a tombstone, right? This one could be another records. So what happens is it reads all of this and figures out this tombstone is actually for this one. So returns this, returns this, returns this, returns this, returns this. Are you with me? Yeah. So these are the records that comes back. It could be records or it could be even columns. I will explain that a little later. Make sense? So at some point in time, somebody has to go out there and garbage collect these two, right? Because this is garbage. Make sense? That is a background process in Cassandra called compaction. The root cause of this is, imagine you are a process and imagine he is a process, right? He is currently busy. Why? Because he is writing something. You got that? Now you also want to write. What will end up happening? You both are competing for the same resource. You got that? So what will end up happening? One writes, so you have to wait. Make sense? That's a fundamental issue. So if I make something immutable, as in, here's a file, once it's written to on the disk, nobody will be able to change it. So now if you have to write, what do? You create another one and you just write it. Got that? Far more efficient. The downside of that is you have way too many files and you're building up garbage like this. So you need a background process which kind of wakes up once in a while, and there is obviously something pre-calculated and predetermined that can go out there and remove all the garbage and compress all the files together or compact all the files together in a single large file, process called as compaction. The moment you start working about metadata, that's a centralized thing. You got that? You are maintaining a central metadata system, maybe on a per node basis. So all the threads that are going to write or read will start competing for that one resource. You got what I'm saying? So the fundamental root cause of performance has been eliminated in a model like this. Well, actually, if you really look at, I'm saying the data resides on a given node, right? And you can say if your replication factor is 3, this is what is happening on those 3 nodes. None of the other nodes are impacted by this. You got that, right? Because you won't be deleting, by the way, in these kind of systems, you can't actually do delete star from, the table. You can't do those. You have to give the primary key. Make sense? So as long as you're giving the primary key, or at least minimum partition key, we'll talk about that, primary key, then only select set of records will be deleted, right? And those select set of records will be there only on the replicas.